This video is for AQA AS Business Studies Unit 4 and Operations. Now, I've already created videos based on capacity utilisation and labour productivity, and they're really fundamental formulas for this unit. But there's also other formulas that you can use to really strengthen your analytical points and to manipulate data within the case study. Sometimes these formulas can go a little bit unnoticed, but they're really, really essential. So therefore, this video is just going over a couple of them. In fact, it's just 3, telling you how you can use it, how to calculate it, and the reason for calculating it. So the first one is punctuality. And as I've written here, it calculates the degree to which business delivers its products or provides a service on time. So imagine if it's, for example, production. They produce a good, they have to deliver it to maybe retailers however they plan on selling that good. And it measures how many of those deliveries are actually on time and their punctuality. If it's a service, it's to do with how punctual they are actually carrying out that service. Now, the example that I've done is a service. I've made a little mistake. I accidentally put 12 months instead of 12 weeks, but we'll just go over that anyway. So imagine you've got a train company in a small town. Maybe due to just the limited services, on a Sunday they only offer one train journey that day, and that's at 12 p.m. Now, what they've done is they've recorded their time management over the last 12 weeks and recorded the following. So 8 times out of the 12 weeks, so for 8 weeks it was on time, okay? It was on time at 12 p.m. However, 4 times, okay, within that 12-week period, they were late. So therefore, you do your 8, you divide it by your 12, times by 100, and that gives you 66.7%. So punctuality is shown as a percentage. Now, 66.7%, is that good? Well, to be honest, I would probably say no, okay? You'd want it to be as close to 100% as possible, because the less punctual you are, obviously the worse your customer service is going to be. Now, they'll have to, again, compare that just to make sure. They might compare it to the last 12 weeks before that. They might compare it to the industry average. They might even want to investigate, well, what is causing these 4 latenesses. Is it to do with labour? Is it to do with maybe the infrastructure of the train tracks? Is it the train itself? And if it continues to get worse, and they'll probably monitor it in the next 12 weeks as well, and if that punctuality starts to fall even further, they might need to actually act on it. If it improves, then again, maybe it was just one of those tricky times where there's external factors that have just been out of their control. Now, it is good, as I've said before, because it does relate to customer service. The higher the punctuality, the better the customer service. The better the customer service, the more chance of repeat purchase. The second one is unit cost, and this is really, really fundamental. It's absolutely crucial you consider the unit cost, because it gives you a really good indication as to economies of scale and diseconomies of scale. The reason for that is because you need to know the unit of outputs, but you also need to calculate the total costs. Now, if you've forgotten how to calculate total costs, just a reminder: you get your fixed costs and you add it to your total variable costs. What I mean by total variable costs, because sometimes it's just considered variable costs, but I consider that to be inaccurate. Variable costs is like the cost of producing one good, but you never just produce one good. You produce, obviously, a stockroom of goods, or whatever the capacity is. So there you calculate it by the output. So once you've got your total costs, you divide that by the unit of outputs, and that'll give you your unit cost. Now, obviously, if your output increases, and you're able to be really efficient, really productive, and manage to actually reduce your unit cost even though you're increasing your output, then you're achieving economies of scale. So in this little scenario, they're producing 100 units of output at a total cost of £1,000, and their unit cost is £10. But when they increase that output to 200, their total costs only go up to 1,600, and therefore their unit cost actually falls. So therefore that's a sign of economies of scale. Because remember, economies of scale is when output's increasing at the same rate as average unit cost is falling. 300, it goes to 7, so further economies of scale. 400, it goes to 6, and then it starts to slow it down slightly. And actually at 500, again, they can assess this, they can explore and investigate the reasons why, but then it could be argued that they're starting to maybe suffer from diseconomy of scale, where unit cost starts to rise. Now, if they produce more goods at that efficiency rate, in terms of 600, 700, 800 units of output, then the likelihood is that that unit cost will continue to rise. spelling out further diseconomies of scale. So unit cost is a good one for really exploring economies and diseconomies of scale. So the final one relates to capacity utilisation, but it's looking at spare capacity. So spare capacity can be used to help to calculate possible sales revenue. And the reason why you might want to calculate this is just to give you an idea as to what you should really be doing in the future in terms of your capacity. Should you be expanding capacity, or do you actually not need to? Because think about the injection or the investment that is needed to boost capacity. It's large sums of capital. So if you don't need to, then actually those costs will not be experienced and that investment will not be needed. But if you do need to, at least you've got the evidence to support that. So a firm could use a combination of calculations to measure spare capacity and also possible sales revenue. This might provide an indication as to whether they need to expand their capacity. If their possible sales revenue is to a satisfactory standard, or if it's spare capacity, they'll decide against expanding. If it's not, then they'll choose to expand. Now, unfortunately, it hasn't given you the whole formula, it's on the next page, so I'll just quickly go over the first bit. So what you've got is you've got your maximum capacity divided by your current capacity. So that's step one. Your step two, I'll just go on to the next page now. Step two is your maximum sales revenue divided by your current sales revenue. But obviously, we don't know our maximum sales revenue yet. That is what we're trying to calculate. So I've just shown you it in an example. So if a business earns sales revenue of 12 million and operates at 80% capacity level, then what you do is your capacity first. Obviously, the maximum capacity would be 100%. Divide it by your 80%, which is what they're currently at, and that would get you 1.25. Then what you do is you times it by your 12 million, which is their current sales revenue, and that'll give you 15 million. So 15 million is their maximum sales revenue at this moment in time. Now, is that good? Is that bad? Obviously, it completely depends on the situation, depends on the industry, depends on the company's objectives. I mean, it depends on the financial, strategic objectives as well, so the functional areas. So the 15 million is deemed satisfactory and in line with their financial objective, then they may hold back on the capacity expansion. If the company has corporate objectives or financial objectives of much higher levels of sales revenue, then they may feel like they have to increase capacity to be able to achieve it.